So what would, if I ask you, which car should I buy? Which car would you recommend me to buy? Would it be something like this? Or maybe something more like this? And if I'll tell you that I'm using the car only once a month, 5 hours every day, will that affect your answer? And as everything in life has a price tag, what if I'll tell you that I only have $1,000 to buy the car? Will that affect your answer? $100,000. Different answers? What about now? Sorry. What about now? Now, faced with those questions, how many of you actually stopped and asked, why do I need a car for? Raise your hand. Okay, a few, right? So for the one of you who did wonder, I will say that I need to go from my house to my work. Pretty straightforward, right? Do you feel like you have enough information now? No. He's shaking his head. So I will even add that until recently, I relocated to London. I lived in Tel Aviv, and the distance from my house to my work was 650 meters. If I'll take into consideration traffic, finding parking space in Tel Aviv, it will take me about 25 minutes to go using a car and less than 10 minutes while walking. Will you still recommend me to buy a car? Any car. So what other alternatives do I have? We said walking. What other option do we have? Bike. Scooters. Public transportation. Running. If we don't have any money limitation, then we can even take an helicopter. Right? We have other alternatives. So you probably guessed it from my questions. The reason, the motivation behind my problem is critical in order to solve it. If we don't understand the customer need, if we don't understand the problem properly, how can we actually solve it? So we first need to understand our problem, to understand the pain. So don't worry, no driver license is required in order to proceed. But if we implement similar logic as we do on our daily life, as we do in our daily life and as drivers to our system architecture, then we'll be able to make better decisions, build better product and better solutions. So hello again, my name is Ayelet Sachto, and I'm a cloud engineer at Google. Resilience, throughput, scale, performance are only a few of the concerns I'm dealing with them on a daily basis in the last 15 years or so. And that's even before we actually had cloud to mitigate part of those risks. And from my perspective, solution architecture is not just for architect or developer. It's something that actually affects us all in the tech world. And it's talking about the product, it's talking about solutions, it's between teams, it's QA, it's marketing, it affects us all. And what I saw during my career is that again and again, even the best engineers struggle when it's come to implement their architecture principles. And from what I saw, it's usually due to lack of awareness and not lack of talent or motivation. And that is why I'm here today. Before we proceed, is everybody can hear me properly or we lose the mic? Because in the back they're saying like this, but...
I think there's some echo there.
Mic or no mic?
No mic.
No mic. They will just turn it off.
Okay, should be good.
Okay, thanks. So, what is architecture? Architecture is translating requirements into a technical solution. And in that process, the complexity, the constraints limit what we build. Our limitations lead us to choose the building blocks that we will use. Now, some of you may think, oh, we can use patterns from that. And we all have, and we are familiar with architecture patterns, we have design patterns. Nowadays, we also have cloud patterns. And for the one of you who are not familiar with the concept, pattern is reusable, a general solution for a commonly recurring problem in a given context. And I'm emphasizing given context because what is important to understand that is, again, the general solution. It's not always suit our case. And patterns are great. They are great solutions, but they're not the entire solution. They are not the full scope of our project. And this quote is something that a former colleague of mine used to say, and I love that quote. If it's not a new problem, it's not interesting to solve. We are not developing solutions to solve the same problems again and again. We are trying to innovate new things. We are trying to solve different things or the same thing in a different constraints and different context. And while we can use patterns for doing that, and sometimes it's even necessary to use patterns, it's not the full solution. And it's something that is important to understand. So let's say we did buy the car. So the one of you who has a car, did you ever use a car wash service? Everybody have dirty cars here. Nobody used car wash service. So I never created or built a car wash service, but I can imagine that it doesn't start from a big enterprise, like a big chain or a big corporation. It usually starts something like this. A person with a bucket cleaning the car. And that is very similar to our own services. Usually, we don't start with a big monster that does it all. We don't start with a big enterprise. We start with some small service that can run or on VM, our local environment as a service, or a Docker container that do something very specific, and during time, we add more and more complexity. We add more and more requirements. And I think that one of the requirements that we first see is accessibility. So for the one of you who did created the service in one point, you want user to actually start and use it. If you want someone to use it, he will need to access it. So if you go back to our service, if we have an amazing car wash service and we are waiting for customers, but they are not able to reach us, they are not able to come to the car wash service and actually use the service, it's pointless. So let's say we do allow access. Now we have different restrictions. We have different constraints due to it. We need to think about security. We need to think about performance. Are we able to accommodate those users? Are we able to accommodate our customers? If we have a car wash service and it's amazing service, but people are coming and they cannot get service, they will leave. And especially when we are talking about a digital world that people are used to fast response and they have a lot of different alternatives. And that's something that is very important to understand in architecture. Everything is a trade-off. If we allow accessibility, we need to resolve different things. We need to think about security. We need to think about performance. And when we will solve the performance issue, when we solve the security one, other things will raise. If we limit the security, if we change the balance, then other things will come along. So who of you saw this amazing structure? For the one in the back that's just raising the head, it's a picture of a bridge. Nobody here saw, except of the guy in the front, nobody saw a bridge in UK? No, not a specific bridge, just a bridge in general. So a bridge is great solution. Oh, great, you're waking up. So bridge is a great solution. It's allow you to bridge, to allow access between unreachable places safely. But bridge is also a costly solution, and sometimes even complex solution. Now, what about this bridge? It's also very massive. It's also very strong. Do you think that this bridge, even though the graffiti, is a great solution? What about now? If you don't get it from the picture, this bridge leads to nowhere. It's actually a bridge that was built in Germany. And if someone is wondering, this is actually its name. And we all have in our services great solutions, great implementation of things that are like our bridges, are like our useless bridges. Things that we started and implemented, but we shifted. Things that we thought there are a great solution, but actually are not really doing a lot. Things that are just costly. Maybe because we pivoted. Maybe because it wasn't a great solution at the time even. So I invite you all to think on your own services and think about your own useless bridges. And we actually quite a small group here. So if someone wants to share an example of a useless bridge right now, people are shy here, okay.
I can't really tell you what it is, but it's a thing like that. But there is a person or two that use it to climb up and do something on top of it, and we need to keep it there for the purpose of those people.
So I'm going to touch on it in the next, but how many of you actually had useless bridges because weird requirement of other people that, or because of problem with communications, partnership, just management, kept them there and did not resolve? Even everybody knew they are just climbing unnecessary bridge. Okay, you are waking up, finally. Sorry? Disappearing? Ah. So somebody destroy your bridge actually. So understanding the constraints is critical part when you talk about architecture. And when I'm talking about constraint, I'm talking about the real constraint in your current project, in your own solution, in this given time. And why I'm saying real constraint? Because sometimes we say, oh, in a previous project, we had that and that limitation. But actually, in the current one, it's not real. Sometimes we even think about budget as our most restrict or the most limiting constraint. But actually, budget sometimes can change. But other things, like our team, like our processes, like the company that we are working on, and how things are working is much harder to change. So in each project, we need to think again about the restriction that we have in this given context. And like the bridge, we have best practices, we have great solutions, but there's no one size suits all. We need to think about how implementing those solutions in our case. And expensive is not always the best. Perfect does not always serve us. Sometimes MVP is great for our own use. Sometimes when we are in a small startup, we just need to deliver something fast. We don't care about maintenance. We don't care about the end game. We don't care what will happen in 2 years. We care about showing some value right now. And I mentioned working in team and where we are working on. So how many of you work in a big corporate or big enterprise? Few. Small startup or a small team? Half and half, pretty much. So if I would suggest the same solution for the one that raised their hand for the enterprise solution, it'd probably be very different from the startup. So what kind of difference there between enterprise and startup that I'm not talking about as a company, as a culture. I'm talking about actually technical differences. Someone can think about an example?
Security and compliance.
Security and compliance.
It's always large scale architecture.
Large scale and architecture. And I actually have a note about it in the next slide, but because you raised it, I have to say it now. People are sometimes abusing the word scale, and a lot of people talk about scale from a different perspective. So people are saying scale, but it actually means different things. And when we're talking about scale, when in big companies, in big enterprises, we usually don't talk about just the scale of the service. We are talking about scale of the development cycle. We are talking about scale of people. And microservices, and we talked about different solutions, microservice is a great example of it. Microservice is a solution for a specific problem that is scale of people, scale of the development cycle. We are working in a lot of teams, we need to maintain it, we need to keep it, we need to collaborate in some way, but we don't want to ruin the same thing. If we're in a startup, monolith is sometimes even better. Like, think about it. You don't have the overage of network. Our monolith does it all. It's very simple sometimes. Like, we don't need to think about integration with other party. We don't need to think about the integration between our services. But if we go back to the enterprise people, they cannot allow that to happen. They need clear definition. They need clear API. They need clear endpoints between those people, between those departments, between those teams. So understanding the constraints is critical when we're talking about architecting a solution. And the best way to do it is by asking questions. So what is the real pain that we are trying to solve? Should it be done like that? How it worked like it today? And if it worked like it today, what was good about it and what's bad? It doesn't mean that if it worked like it's like in the last 2 years, it's a good practice. Actually, maybe you can learn what not to do next time. And questions allow us to challenge ourselves and others. And by challenging ourselves and others, it allows us both to think about the design, think about those challenges, and make better decisions. And by that, build better solution. And you may think like it's, oh, I need to add another step, and people don't really like it when I'm asking questions. But we actually do it automatically without realizing every day in our life. So taking aside right now the laws that we have in our society and in our country, would you drive the same speed when you are on the highway or next to a school inside the city?
Yes.
Hopefully not. Hopefully not. Maybe you don't really like children. I don't know. Would you buy the same car if you use it 40 hours a week versus 40 hours a year? Probably not. We have limited resources and we want to put it and use it in a smart way to utilize what we have the best way we can. And part of those questions are things that we do without thinking, unconsciously. And when we're coming to system architectures and solution architect, we actually need to stop and think about this logic, think about those questions. Why? Why do you think this is the right solution? Why do you need it like that? What is the requirement? I'll share with you a few examples, and sometimes people don't like it when you ask questions like that. But I want to give you 2 examples. One is that by asking question, what do you mean by going live today? I saved the company about $250,000. And another example, that by asking questions, we actually create collaborations. So the first example is that before I was a cloud engineer, a few years ago, I was a platform engineer. a team leader in a small startup that was bought. And the platform team is between app team, between R&D, between ops, and between product. And the product team saying, oh, R&D said it can go live. R&D said it can go live. But when they said it can go live, they meant it can be deployed. Product team meant we can push the button. Ops team meant, well, it can go live, is that they have the infrastructure set and everything, but they didn't even deploy the infrastructure. So by asking each one of those teams, what do you mean when you say it's ready? As you can understand from the question that I ask and the example, is that by not pressing that button, we saved a lot of critical transaction and actually bleeding money issues that could arise from it. The second thing that I want to mention is actually because in the last talk I gave, a lot of people ask me, a lot of the things that you are talking about, I don't really have the power to decide. I need to work with people and I need to make them buy my product. I need to convince them that this is the right architecture, even if I know it. And sometimes as a developer or engineer, don't really have the management or the leadership power, let's say, to make them. And I want to emphasize, it's not making them. It's collaboration. It's creating partnership. It's working together. It's getting the buy-in or your idea. And the best way to get a buy-in, the best way to create collaborations and partnership is also by asking questions. Show involvement. Sorry, typing my password that I just changed. You know how much it's hard. So for example, let's say you're working on a project. You can ask someone else in a different team, oh, I remember you worked on something similar. What was your concern? What did you thought about? And by this simple question is, first of all, you grow yourself as an engineer. You think about things that you didn't thought about. And the second thing is that next time, maybe it will be more open to come to you with those questions as well. You opened the door for communication. And that doesn't really relevant only in the R&D world. You can ask the same thing in your product team, your ops team. It depends on your organization. But ask questions. Build those bridges. Not the useless bridges, but the real bridges. And I mentioned it before, understanding the context. Understanding the restriction, our environment, the team that we are in. How much time do we have? If we have one day, it doesn't really matter if we have the best architecture. We need to deliver in one day. If we have a small team of 4 people, it doesn't really matter even if we have a budget of $1 million. It will take longer time to build. If we're in a small startup, maybe people will be more flexible regarding the language that they want to use, but will be less flexible when it comes to budget or when it comes to timing. And the opposite, if we are in a big corporation, we'll be more flexible when it comes to budget, resources, but less flexible when it comes to processes or methodologies. So those requirements, those limitations, even if it's not technical, they are still deciding the fate of our solution. So as I mentioned, I recently relocated from Israel, and I grew up in the north of Israel, but actually lived in Tel Aviv. And to go from Haifa to Tel Aviv, we have the shore road. It's called Route 2. And I love this road, especially in its beginning, because as you can guess from the name, you can see the shore. And it's really beautiful, and it's well maintained, and it's pretty new most of the time. Most of the section, sorry. But what will happen if in the middle of the road, let's say between Haifa and Khadera, a car will turn over, or a truck, and will block that road. You don't want all the people from Haifa will not be able to reach Tel Aviv, or vice versa. You have a lot of people that work in Tel Aviv but actually live in Haifa. Maybe there's people here that live in Reading but actually work in London. You don't want to block all the way to get there. So you want to think about the solution that even though there's a problem with the road, you will be still available. It still be available, and you will still be able to use it. You will still able to reach your goal and to your destination. So there's another road that wasn't even mentioned by Google Maps if you saw before. It's called Route 4. It's the old Shore Road. And it's not well maintained. It has a lot of traffic light. It has a lot of distractions. Go basically through the city, so it's much slower. And again, it was not even suggested before. But if a truck will turn over, that is your best way. It will not be as fast, but you will still be able to go from Haifa to Tel Aviv. So the road is, as you can guess, highly available. And we need to think about it in our own services. Now, not every service needs to be highly available. If we have ETL service that only do something specific in 12 hours, when we have a long delay that we can stand, we don't need it to be necessarily highly available, because highly available costs money. And highly available costs resources, human resources as well. So for the services that is customer facing, for the services that are critical, and otherwise people will just get stuck and will not be able to get home, you want highly available service. And another example that if we can compare it to our services, so maybe we have customers in Europe and US, and when the Europe site is down, we'll point them to use the US service. Now, it won't be as fast, it won't be the best solution, but it will be a solution, and they will be able to work, and we will not lose our customers. And I want you also to think about, and you were like a little bit participating before, so hopefully you will participate now as well. There will be still users, still drivers that will be able to get through even if the road is closed. You can think about a few examples. Cars that will be able to go even if the road is closed. No one?
Make a ferry.
No, the same road. People on the same road will be able to pass. Police, ambulance, rescue teams, they will be able to pass because they have high priority. They have special paths that they can go through, even in critical situations. And I invite you, when you think about your service, to think about your priorities. Do you have transactions, customers, that still need to go through even if everything is burning? Usually it's the payment one, right? Even if your entire service is done, you still want to save those money transactions. You don't want to lose money. So for those one, you will need to create those special allocation. You will need to find a path to accommodate. You will direct them to US. You will save it in the queue and resolve it later. But in order to do so, you need to think about it in the beginning when you architect the system. That takes me to the next point. Setting priorities. Understand if your services need highly available. Understand who and what are the critical transactions in your service, and accommodate that in your design. Someone else have a different example of priority that he want to share or she want to share? You don't have priorities in your jobs. Okay. Priorities can go ahead.
Healthcare data, it must be correct.
Okay, so I I mentioned it before when I talked about the concerns I'm dealing with on a daily basis. And when we're talking about, I don't want to go too technical for the people in the cloud, in the cloud, in the crowd that are not dealing with it. But we have different constraints. We have constraint of performance, we have constraint of resilience, and we have constraint of accurate information. And sometimes we need to do the trade-off. We need to decide what is more critical. And if we are talking about distributed systems, we cannot accommodate for everything. We need to choose which one are priorities. So if we have healthcare system or a banking system, sometimes we will prefer that a user will not be able to do the transaction than to do the transaction and it won't be accurate. If you're getting money or you want to check your balance, it's better that they will reject the card, just remove it, and you will not be able to do the transaction than you will do it and something will break on your information side. Like maybe for you, if you're getting $1,000 and your balance stays the same, it's better. But from the bank perspective, they prefer it to be accurate. And mostly we are too. I want to touch on traffic. When we're talking about traffic and traffic at services, we have so many different varieties. Maybe your service looks something like this, but maybe it looks something like this. And when we're talking about traffic and the patterns and the trends that we have, we are basically talking about workloads. Our workloads, our loads define and drive our traffic. And we have different types of traffic. And when I'm talking about traffic, we are talking about trends, we are talking about expected behavior, at least when we architect the system, because in real life, trends can change, service behavior and expected behavior can change, but when we architect the system, we need to think about what is the expected behavior, at least in the first phases. Do we have burst of information? Do we have rush hours like in the road? Are we growing fast and we need elasticity? Do we have on and off any periodically behaviors? And when we design our systems, it's critical that we understand it, because one, if we are in the cloud, it's easier to be elastic. It's also very cost effective. But also when we're talking about maintenance. So if we have a service that all the time is running on 80%, never mind what is the 80%. It's really easy, right? You can identify abnormal behavior really fast. If it's go above 80, there's a problem. If it's go below 80, it's a problem. But what happens if you have on and off and it keeps changing? It's very hard to think about monitoring. It's very hard to think when there is something wrong. So you will accommodate those behavior by their behavior in production. And when we're talking about services, we're talking about thinking about their behavior in production, we need to remember that production is only the beginning. When we press deploy, and sometimes developers forget it, when you press deploy, when you release your code, is only the beginning of that code lifetime. You need to maintain it. You need to verify that the customer can actually use it. And to do so, you need to make sure that you have the right monitors, that you have appropriate logging, that you can debug it. And something that sometimes people forget, you need to make sure that it's flexible, that it's easy to add and remove functionality. Because let's say I build a massive solution, the best solution ever. I'm so proud in that code, but any change that you need to do, the developer will take 2 weeks to do. Changing one line of code will crash your service. It's not very flexible, it's not very effective, and it will cost the company and you time and resources that usually you cannot accommodate. So thinking about flexibility, just Not build everything, just think about the option to add and remove components. And when we're talking about maintenance, I have one main guideline. So I worked in platform engineering teams, and when someone asked me what should be my guideline regarding documentation, how much I need to write inside, how much I want the code to be clear, I basically told him, what do you want to see when you're waking up in the middle of the night? So let's say, not you specifically, but your teammate. You're waking up in the middle of the night and you got the alert. Is it clear enough? How long it will take him or she to understand the problem and actually solve it? That time, that resource, time to sleep, is the measurement, at least for me, to know how complex the problem and debugging is for your service. And it's really also friendly-wise, because if you build a service, even if it's very stable, but when it's crashed, it takes 2 days for another developer to debug, they don't really like you anymore. When I see like one bug that I'm getting up in the middle of the night and it's hard to solve, okay. Twice, when I go to work, I really hate that person. It's not really friendly. It's not building bridges. It's not building partnership. And it's not really the concept of ownership and building sustainable and maintainable services. And another thing that people keep forgetting, developers and engineers, everything costs money. Not just infrastructure. Time costs money. Resources cost money. The time that it takes to debug and solve the problem costs money. Adding functionality costs money. And when we're designing, we need to think about it. We need to think about not just the cost in the first step, not just the infrastructure that need in the first step, but when you grow or when you change it, how money and how many resources it takes. So if we recap, when we're talking about solution architect or system architecture, from the need, we create a solution. And in that process, we need to understand our problem, understand the constraint that we have. Of course, because we're going live, then it will happen. Sorry. Someone see the pointer? You think it wasn't planned, but it was planned, so you pay attention. So we start with understanding the problem, what we're really trying to solve. We need to understand the constraints, our context, the priority. Each service has its own priorities. Each team has its own constraints. Do we have DevOps methodologies ready? Do we have tools in our disposal? We need to think about it. We are not building everything from scratch, usually. We need to ask questions, and that will help us grow and build better solutions and better products. And remember that production is only the beginning, and cost is not just infra, but it's something that is relevant to all of us right now. It's developers, it's engineers, it's the stability of our business. And by allowing this one, yeah. So if there's one thing that you can take today, I hope it will be that architecture is not that scary. And if we all implement similar logic as we do in our daily life as drivers or off the road to our system architecture and understand the principle behind it, we'll build better solutions.